Question number 1. A uniform horizontal beam. This is a uniform horizontal beam pivoted at its hand end. This is right hand end side is in equilibrium. It means sum of all forces is zero. So we have two possibilities for equilibrium. We have two possibilities. The first thing is sum of all forces acting on it is zero, and sum of all movements acting on it is zero. This is the condition for equilibrium. A force of 60 Newton acts vertically upward. Here is a 60 Newton force which is acting vertically in upward direction on the same beam as shown in figure. Okay. What is the weight of the beam? Weight is acting in downward direction like this. Okay. So you can see this force is going to create an clockwise movement in it. This is clockwise movement in this beam, and this force is going to create an anti-clockwise movement in it. So as per rule, clockwise movement and anti-clockwise, if the object is in equilibrium, then sum of movements is zero, or you can say clockwise movement and anti-clockwise movements are equal. So clockwise movement is equal to anti-clockwise movement. So for a movement, the formula is, for a movement we know that force times perpendicular distance. This is the formula for moment. So let's see. Here is a force which is 60 newtons in upward direction, and there is a perpendicular distance from pivot, like this is a perpendicular distance and this is the force. Force and distance are perpendicular to each other. So total distance is 50 centimeters. Suppose 20 plus 30 is total 50 centimeters, and the force is 60 newtons. So we can calculate a clockwise movement as 50 is the length and 60 is the force, and it would become 3000. Okay. For anti-clockwise movement, weight is acting in downward direction like this, and perpendicular distance is 30 centimeters. So we can multiply 30 multiplied by weight would become okay. So weight would become equal to 3000 divided by 30, and it would become 100. So our answer is this one. Okay, now question number 2. 4 lamps are shown along with position M. M is center of mass. Position M of center of mass. In each case, which lamp is the most stable? So there are two conditions with respect to stability. For stability, we have two conditions. The first condition is like center of mass is lower. If center of mass is lower, then object would be stable. Second condition we know is base area is large. BA for base area is large. When we have these two conditions regarding any object, that object would be stable. So let's see, you can see this object has small base area, so its stability is little small, and its center of mass is at some distance, so it looks unstable. Similarly, its base area for B is, so I'm gonna cross this one because this is not possible. Okay, so you can see both of them have comparatively same, like this one is little lower, and base area is comparatively little more than this one. So B would be more stable than C, but not with respect to others. So we are also going to cross this one. Now let's compare A and D. Both A and D looks quite similar to each other. But if we compare their base areas, look at the base areas. The base area of A looks little larger than D. And center of mass for A is comparatively lower. So A is following these two conditions more than D. So that's why we are going to consider A and going to ignore the D. Otherwise, D looks more stable than B and C. But with respect to A, its center of mass is little higher and its base area is little lower. So that's why we, in comparison, A is more stable than D. Number 3. A plank is pivoted at its center. Okay, here is its center and its pivot point is here. Two weights are added to the plank. One weight is here and this one is here. One weight on each side pivot position as shown in figure. Both are at 2 meters from the pivot point. A vertical force is applied at X like this to the balance. Okay. What is the size and direction of this force? You can see the where is okay, this 8 Newton force is acting in downward direction and it is going to create a clockwise movement in it. This force is going to create a clockwise movement in object, and 12 Newton force is going to create an anti-clockwise movement in it, kind of anti-clockwise movement in it. So you can see the force on the left hand side is 12 Newton, which is 12 Newton, and the force on the right hand side is 8 Newtons. So the moment created by this force would be larger than this one. For stability, one force is expected to be applied on this direction so that some clockwise movement would be generated to counter this some anti-clockwise movement is applied here, so that the sum of these two clockwise movements will balance this anti-clockwise movement. Okay, let's calculate. Like as per rule, we know that clockwise movement is equal to anti-clockwise movement. So clockwise movement is force into perpendicular distance. So force is x and distance is 4 plus force is 12 and distance is 2. In clockwise, sorry, I mixed things. Okay, force is 8 and distance is 2. And the anti-clockwise movement is force is 12 and distance is 2. So it would become 24. 8 times 2 is 16 plus 4x. So now 4x would be equal to 24 minus 16 would become 8. 24 minus 16 is 8. So divide both sides by 4 and it would become 2. So you can see the force X is 2 newtons and it would be in upward direction. So 2 newtons force and upward in direction. So like the option is A option looks wrong because the force is downward. B option is 2 newtons correct and upward direction. That's fine. Okay, this is the correct option. Number 4, a beam is pivoted at a center. Here is a beam which is pivoted at center. Two weights are placed. One weight is here and other weight is here on the beam in the position shown, and the beam is balanced by the force by an upward force F. Like it's a kind of similar question, but right, like question number 3, but here instead of X, F is mentioned and its direction is already given. So we will have similar strategy. So you can see like the 30 Newton force is going to create a kind of anti-clockwise movement. And look at F. F is also going to create an anti-clockwise movement. Both forces are going to create an anti-clockwise movement. And look at this 16 Newton force. It is going to create a clockwise movement like this. Like this. Okay. So let's apply the formula in which clockwise movement and anti-clockwise movements are equal. Anti-clockwise movement is like we know that force movement is actually force into perpendicular distance. So force is for anti-clockwise movement is 30 Newton, which is in downward direction, and its distance from the pivot is 40. The second anti-clockwise movement is by a force F at position, and the perpendicular distance is 30 plus 20, which is 50. For clockwise movement, the force is 60 newtons and the distance, perpendicular distance, is 30 newtons. So 60 times 30 is 1800, and it would be 1200 plus 50F. Okay, so 1800 minus 1200 is 600. So 0 is cancelled with 0. We are left with F equals 60 divided by 5 is 12. So our force is 12. And look at the option B here. The option B is also 12 newtons. So correct option is this B, which is 12 newtons. Okay, let's look at the number 5. Total weight of the load and wheelbarrow shown is 600 newton. Total weight is acting in downward direction, which is 600 newtons. Pivot is here. So you can see weight is going to create a kind of clockwise movement in it. Yes, it is going to create a clockwise movement in it. Here is an upward force F, which is going to 1 second. Which is going to create a clockwise or anti-clockwise movement in it, like this. So the red one is going to create a clockwise movement, and the green one is going to create an anti-clockwise movement. So what is the question? Question is, what is the size of force F? This is force F needed just to lift the load. It means how much force is required to create a anti-clockwise movement. So let's use our general formula, which is related with equilibrium. Clockwise movement and anti-clockwise movements are equal. So clockwise movement is force into perpendicular distance. 60 Newton is the force and perpendicular distance is 70 newtons or 70 centimeters. Similarly, for anti-clockwise movement, the force is F and perpendicular distance is 120. So oh, okay. Sorry, there is a mistake of 600. Force is 600 newtons. So now you can use calculator to find out. So 12 times 3 is 36. Now it would become 60. 12 fives are 60. 12 zeros are 0. So your answer is 350 newtons. So the correct option is 350 newtons. A beam of length 40 centimeter is pivoted at one end. A beam of 40 centimeter. It means this beam is 40 centimeter long and it is pivoted at one end like this. The weight of the beam is 4 newtons. And here is the weight which is acting in downward direction. Okay. Acts at a point of 20 centimeter from the pivot point. Okay, it is like the weight is 20 centimeter, 10 centimeter here and 10 centimeter here. So overall it is 20 centimeter from the pivot point like this. This is the pivot point and weight is acting at 20 centimeters. A 2 Newton weight hangs 10 centimeter from the pivot. A 2 Newton force is also acting in downward direction, which is at 10 centimeters. Okay, what's the question? The question is that, okay, an upward force U, here is an upward force U, needed to keep the beam balance. So like in order to create an equilibrium or balance, you are going to apply an upward force. What is the size of U? You need to find out the size of this force. So you can see these two forces are actually going to create like the upward force is looking to create a kind of you can say anti-clockwise movement in it. This is an anti-clockwise movement. And what about these two forces? These two forces are going to create a kind of clockwise movement in it. Both the like these two forces, 2 Newton and 4 Newton, are going to create a clockwise movement, and this U is looking to create an anti-clockwise movement. So we know that clockwise movement and anti-clockwise movements are equal. So clockwise movement is generated by two forces. Like the first one is 2 newtons times 10 is the distance. And then we have 4 newtons and the distance is 20. And anti-clockwise movement, force is U and distance is 40. So now let's calculate. 2 times 10 is 20. 20 times 4 is 80. And it would become 40U. So overall, this is 100. And it is 40U. So 0 is cancelled with 0. So 10 divided by 4 would become 2.5. So U is an upward force which is 2.5 newtons. So our correct option looks C.